ISHRI, Indian Society of Heating, Refrigerating and Air Conditioning Engineers. Founded in 1981 at New Delhi by a group of eminent HVAC and R professionals, ISHRI now has a total of 41 chapters and sub-chapters.
ISHRI gives you the latest industry insights of the HVAC and R and building industry and delivers latest technologies in forms of technical blogs, videos, and articles to people. It has more than 14,000 members and about more than 10,000 student members. ISHRI releases various standards for HVAC and R building industry time to time. It organizes more than 800 events every year, including seminars, conferences, product presentation and more. ISHRI also provides handbooks and guidelines. ISHRI also has student chapters in more than 150 engineering colleges, to encourage students, and let them know about HVAC and our industry. Visit now, ishri.in, for more details.
Ravi, is the screen visible?
Yes, sir, your screen is visible.
Okay.
And
Good evening. Yeah. Good evening. Welcome back to the webinar series, Refrigeration Applications by Using Natural Refrigerants. Today is the 5th session, wherein we will be discussing on the steps to build modern and energy efficient cold storage by Mr. Ramesh P. Paranjpai, who has the MTech from IIT Mumbai and fellow life member of ASHRAE. Okay, we welcome you all once again for this session, and let's all look forward. I'll have we'll complete the introduction. Shri Ramesh Paranjpai, the fellow life member of ASHRAE, the distinguished 50 years service award winner from ASHRAE in 2020, member for the ASHRAE Fundamentals 2017 volume. He was the committee member, then member of IIAR USA, and he's having a degree post-graduation MTech in refrigeration from IIT Mumbai. Professional experience is 6 years as the Chief Executive Officer from Voltas Air International Limited, Pune. Prior to that, 4.5 years, he was the Managing Director at Carrier Refrigeration Limited, both Bangalore and Singapore. Prior to that, for 27 years at the Air Conditioning and Refrigeration Division of Kirloskar Pneumatics, Pune, and he was the Vice President when he left Kirloskar. Shri Paranjpai is also the examiner and paper setter in the University of Pune for Master in Engineering, and also he was the syllabus formulate. He was in the syllabus formulating committee. Paranjpai has published more than 45 papers in international and national journals, conducted more than 300 training programs at Honeywell, Alfa Laval, Voltas, Blue Star, Thermax, Emerson, Tata Motors, LG, ISHRAE, and ASHRAE forums, and on international level in US, Singapore, China, Germany, etc. So the award of recognition from ASHRAE is for meeting ASHRAE objectives in sharing knowledge and information through publishing papers and conducting training programs, as well as promoting arts and science of refrigeration and air conditioning. It's a big honor to be selected by ASHRAE for and getting this particular recognition. So achievements, our speaker today, Sri Paranjpaji, was invited by German Chamber of Commerce to deliver lecture in Germany on ammonia pump circulation systems for low temperature applications. It was in the year 2008 and presented a paper at IIR conference in Macedonia on energy saving techniques in ammonia pump circulation systems. He was also the winner of Braille System Design Award in the year 2009, winner of the Lifetime Engineering ICE Danfoss Global Chain Award in 2012, published book on cold room solution for Emerson Climate Technologies, then published book for Danfoss Controls, how to use ammonia, making it easy and safe and to be efficient in the year 2012 to 2015. Published book on air cooler design for cold storages for Alfa Laval during 2015. He has executed more than 700 projects for cold storages, ice cream manufacturing, then process plants, fish and meat freezing, as well as air conditioning such as international airports, office building, shopping malls. Sri Paranjpaji resides in Pune and the address is here. He has the email ramesh.paranjpe@gmail.com. His cell phone number is there and there's a website. And now I invite our honorable speaker, Sri Paranjpai, to take up today's topic. Sir,
Yeah,
you can take this screen from.
yeah. I'll just take my screen, enlarge it, and then I will take over.
Yes, sir.
Okay. You can see
I'm
my
muting.
screen. Yeah.
Yes, sir. Your screen is visible.
Screen.
Okay. So I'm proceeding now, and all of you can hear me, I believe. And I thank Anish, Ravi Kumar, and Ishre for giving me this opportunity of sharing my experiences over last more than 50 years in the field of air conditioning and refrigeration. Air conditioning and refrigeration is my passion, and besides this, to be very frank with you, I do not know anything else in uh, engineering, because lot of people ask me, why don't you teach heat transfer, why don't you teach this thermodynamics, and I tell him that no, my specialization is refrigeration air conditioning and I'll stick to that. Anyway, so today we are going to discuss a most talked about subject, which is cold storage design. Now you people must be wondering that you have heard so many seminars on this cold storage. What am I going to talk differently? So my subject, what I'm going to do is I'm not going to discuss load calculations, because load calculations is all discussed every time by all the people. I'm going to discuss how to build a good cold storage, because if you build a good cold storage, your 70% problems are resolved. And I have divided my presentation in two halves. The first half is a green field or a new cold storage. And the second half I am going to devote on existing cold storages where people face problems, and how to solve their problems is one of the major requirements of the industry. Many people have problems. I have summarized few problems and we will discuss that also. So to begin with, let us start. Next slide. This is as I mentioned, is a greenfield project, and I will be talking about uh, new projects. So when customer comes and he says, look here, I have some excess capital and I have seen so many cold storages. I would like to invest my money into a cold storage and I want to have this kind of something to uh, investment. So, but I want minimum investment. I don't want to waste all my investment into cold storages. So minimum capital investment, then I should not have continuous running expenses, minimum electricity bill. If I store some product, I do not want weight loss. That is, I load 1,000 tons and get 980 tons or 970 tons. Also, product quality should not deteriorate during storage. Otherwise, people will say that this cold storage is no good. And I'm not in a very advanced city. I need an operator who can easily manage this cold storage. So these are basic requirements of a owner. Now, to meet these expectations, normally what I have seen when engineers come to me or when we go to design a cold storage, every engineer these days comes with a laptop, opens the laptop, and whatever customer starts saying, he starts feeding it into it and starts calculations. It is not important that what calculations you do. Lot of softwares are available and you can do cooling load calculations. It is very important that you discuss pros and cons of various products. Whatever he has in mind may not be the best product to store. You should be able to tell him different properties of different products and temperature, humidity requirements of each product. Then construction of building, where he wants to construct the building, how to construct the building, how to select the insulation, product handling and loading methods, then proper air distribution and selection of refrigeration plants. Now, all these things you should discuss with him as if he is your partner. Then only he will develop confidence in you and then he will be able to come to a conclusion that whatever was his original idea of this thing is no longer valid and he has learned a little bit more on various uh, subjects. So we need to quickly go through. All of you know this field of applications: positive temperature applications, dairy products, fruits, vegetables, blood storage, floriculture, horticulture, meat, fish, and miscellaneous dry fruits, spices, etc. This is the positive temperature cold storages. Low temperature cold storages are frozen meat and fish, and most important is ice cream. Now, these more detailed lists are available either in refrigeration volume or our book published by Association of Ammonia Refrigeration, which is written by me. I have written in all two books on cold storages. One I wrote for Emerson long back, about 7-8 years back, on all HFC, HCFC cold storages. We call it cold rooms because immersion products are suitable for cold rooms, that is small capacities. Whereas cold storages means it is a larger cold storage, minimum 2,000 ton capacity, going up to 20,000 ton capacity, and multi-purpose rooms, multi-rooms, etc., etc. So let us discuss this. This is the same slide. Ice cream, frozen food, chilled bakery products, milk, fresh fish, and frozen products. So more important is when you store a multi-product commodity, you must tell the customer that the products have their own characteristics. As two human beings cannot be common, every human being is an independent person. He has little bit different characteristic than all other human beings. He is unique. Similarly, in products also, bread and apple, they have different shelf lives. Bread can be kept only for 48 hours, whereas apple you can keep in refrigerator for a long duration or in a cold storage. Onion and mushroom, they have different humidity requirements. Onions require very low humidity, whereas mushrooms require very high humidity. So they have different humidities. Banana and mango, lemons and oranges, the temperature requirements are very different. Banana and mango cannot be stored at 3 degree or 4 degree, requires 10 to 12 degrees centigrade temperature. Lemons, oranges, other fruits can be stored at lower 3 to 4 degrees centigrade. And then most important point is avoid cross contamination. That is, if you are having multi-product cold storages, two products of identical type can be stored, but it is better to store the products in different rooms. For example, garlic and butter cannot be stored together because butter will get the smell of garlic. Similarly, fish and milk cannot be stored together in the refrigerator. You will find your milk will get smell of fish. Flowers and dairy products also are not possible. If you keep some flowers in your refrigerator, your dairy products will start smelling. So this cross contamination is important, and the temperature humidity requirements are important. Then you have to discuss with customer whether his storage is going to be an immediate consumption storage, that is short-term storage, or long-term storage like apples, potatoes, chilies, onions, etc., or frozen storage with fish, chicken, meat, cream. He may be very near to the airport, in which his time will be very short. He may be storing for 1 or 2 days because it gets loaded into the aircraft. But if he is away and if he is wanting to store for making profits for long term, then he should be willing to wait for 7 to 8 months till the next season starts. Frozen storage also is a periodic production. Fish is only for 3 to 4 months, then 8 months you have to store and consume during festival seasons. Chicken, meat, ice cream. Ice cream is a regular consumption, but the demand is more in summer. Now, another important point which I wanted to stress is fruits and vegetables versus meat, fish, or ice cream. Fruits and vegetables are considered as a live product because even if when they are planted, they grow, they mature, but the decay starts as soon as you harvest them. When you remove from the field, the decay starts. But don't assume that the product is dead. The product does not die. It has some life. During growing stage, the roots provide water and minerals, and leaves provide sugar, etc. But once it is plucked, all these resources stop, and they have their own internal resources to last for few days, or depending upon their shelf life. For example, if you see potato, onions, apples, citrus foods, their respiration rate is very low and they have a long life. Lettuce, cauliflower, strawberry, a moderate rate, a short life. Brussels sprout, spinach, very high respiration rate, very short life. And asparagus, mushroom, very high respiration rate to extremely short life. Now this, why I'm showing, it is like a human being. Human being also, people say that if your pulse rate is more, then your life will be reduced. So do meditation. They say this tennis player, for example, Bjorn Borg, he had a very slow pulse rate and he was considered as a very cool player, not getting disturbed so much. So now in animals, for example, dogs are constantly breathing in and out, and therefore they have a short life. Whereas other animals like tortoises, they have a very long life. Their breathing rate is very low. So this is a respiration rate. I just gave some comparisons so that you will remember these important points, because this respiration load has to be taken into account in addition to the sensible load. Now there are some controlled storages for very expensive products like apples, pears. They are very expensive products and they can be stored in controlled atmosphere. Controlled atmosphere is our normal atmosphere is 21% oxygen and 78-79% nitrogen. So what we do in controlled store, we reduce the oxygen content, we increase the nitrogen content, and therefore we reduce the rate of respiration. We keep too low oxygen, 3% around that. So from 21% we reduce to 3% and increase the carbon dioxide percentage to 3%, with the result that the respiration rate comes down and the life of the product extends. Apple can be stored for 7 to 8 months in a CS storage. But this is a dangerous store, because if you try to open the store, there is a possibility of suffocation, because oxygen, you are exposed to atmosphere which is having only 3% oxygen content, and you may fall sick. So be careful when you are operating into CS storages. Anyway, now let's go into how to design a good cold storage. So designers' responsibilities, what are these? Selection of refrigerant, efficient equipment selection, then advanced, that is heat exchangers we discussed in our last session, proper air circulation. Now this is a very, very important subject, that is throw, spread and drop. These are the three terminologies. Throw means how long the air can reach, spread means how wide air can reach, and drop means how high or low air can move. So all these three things need to be considered. Then minimum weight loss, then precise temperature control. Anywhere in the cold room, across the room, the temperature variation should not be more than 0.5 to 1 degree, maximum 1.5 degrees centigrade. This is important. If you check your cold storage and find out what is at different temperatures at different points, you will come to know whether your air circulation is proper or not. Quick pull down rate is important, and reduce maintenance cost. Now let us go to the next distance. When you do load estimation or design basis review, use software, as I mentioned, only after you learn the basics. I have come across many engineers, even abroad, they send the cold storage calculations. When I calculate, it is very much different one than what they have calculated. My load was, for example, I did a job of in Saudi Arabia. They had calculated, the consultant had calculated there the load as 1200 tons. And when I calculated only 450 tons. I said, how can it be such a big difference? So he sent me the software, and there were so many errors in that software, what data he had fed in. And then I had to spend nearly one and a half month to convince their consultant that where he is making mistakes. And my load calculations, I gave them the full manually done calculations and said that tell me where is the error. They couldn't finally, and then the cost of the project came down drastically. So it is very essential that the basics are important. You must know all the points and then come to common understanding what customer and you decide. So it is very important also to prepare a joint signed statement. because customer should not later on say, no, this is not what I wanted. I was expecting this. So it is better to have, to avoid the conflicts, a, a joint statement, which is signed statement. So both the teams are very clear what we are going to do together. High temperature, low temperature cool rooms have different requirements. Multi-temperature cold rooms have different requirements. Refrigeration selection, we already discussed, will be only talking on natural refrigerants and particularly with ammonia. Then next point is load estimation. As I mentioned, do use software. No doubt you must use software, but first learn the basics and please check also with some basic calculations whether your software load and your calculated load is more or less coming nearer. The software is to be used only for speeding up the process, but for accuracy and for confidence building, load calculation. I am an old timer. I prefer to do manual calculations. Anyway, the young engineers today can do software. I am not against software. I am also using software. Construction of insulation is important. Then most important point is avoidance of moisture. We will go into more details that later on. Equipment selection based on load parameters. This is very important. I will touch upon it. You must calculate the base load and the full load. The base load is a minimum load when your product is stored and already cooled down and 4-5 months have been passed and it is just getting stored. That is the base load. And the peak load is when you are doing the loading, unloading session. So both loads you must calculate for selection of equipment. If you have multi-purpose rooms, 3 rooms, 4 rooms, 5 rooms, 8 rooms, then you can use load diversity factor because you are not going to load all the rooms at a time with full load or whatever load we decide. Evaporator selection is air quantity requirement is important. Product loading practices are important and defrost loads and its effects are important. Components contributing to heat load, all of us know. Location we must know because air properties change based on location. If it is a cold storage at Simla or if it is a cold storage at Ahmedabad, the properties of air will be different, or Bombay. So that is important. Then type of product to be stored, frequency of door opening. How is cold storage is going to be operated? Is it daily loading? Is it long-term storage, etc., etc.? Type of insulation, thickness, product loading rate, method of internal and external packaging of the product is important. And then product load, you have to calculate sensible, latent, and for live products, respiration load. Transmission load, that is coming through your cold storage. Air change load, it can be, there are 2 types of air changes load. Some products require, they generate ethylene or carbon dioxide and then air needs to be replaced. So that is by design. And others are by default, that is air leakage. You don't know. When you open the door, the air leaks in. There are so many openings, air leaks in, etc., etc. Air change load by designer and other loads like lighting, fan motor, occupancy, etc. The building planning is important. I'm going to discuss more details on this rather than load calculations. Roof type, planning of anteroom to ensure that outside air and cold room there is a barrier in between. So directly outside air doesn't leak into, or when you open the door, it comes into the cold room. There is an in between anteroom. Office location where you are having office, rooms for expansion, very, very important. Most of the cold storage owners, they expand after 1, 2, 3 years. they want to double their capacity, triple the capacity, etc., etc. If it is a good cold storage, the product is in demand. Separate entrances for people to enter and product to enter. Fire protection is important because many cold storages you must be reading in paper that there is a fire and the whole thing got spoiled. Docks, loading, unloading docks for the trucks, parking spaces for the containers, trucks, vehicles, etc. And most important is waste material disposal area. You must decide where you are going to dispose of the waste product. This is important, especially for fish, meat, and some vegetables. Number of size of door openings, they should be minimum. Then strip curtains should be there with the doors, and as preferred, sliding doors are suggested instead of regular types, both flaps opening. The controls, air cooler controls, always mount them outside the cold room, not inside the cold room, because inside the cold room temperatures are low. Operators are reluctant to work inside the cold room if some adjustments are to be done, and then it becomes a problem. If it is outside in the open area, it is easy to operate the plant. I always on my all cold storages, I keep all the controls outside except the air cooler. Nothing is inside the cold room. The next slide, what is the size and the shape of the cold storage? So size and the shape of the cold storage, the cubical shape is preferred than rectangular shape because same internal volume you will find aspect ratio, that is surface area to floor area, cubical shape is more preferred because it has less exposed area. The aspect ratio is only 6 as against 7. So this is aspect ratio is important. Next important is box in and box out design. If you are constructing a cold storage, do not have any steel members coming inside the cold room. It should be a vapor tight separate insulation box. That is a big box. That is a cold storage. The structure should be, all structural members should be either totally outside, nothing to penetrate inside, or next is your box out design. That is everything everything inside the entire structure is enveloped in a insulated system. So these are the two designs. Don't compromise in between and some steel members coming inside. Then flow of product, whether you want to have a straight flow like a IQF, L shape depends upon your cold storage room where you want to store the product, or U shape. This is dependent upon your storage room where it is located. So these three flows are important uh, for planning purpose. Now these pre-engineered buildings, when you plan, minimize columns, high ceilings to avoid condensation, racking, minimize painting. No painting should be done inside, and minimize, last point is minimize flat edges and corners. Have all the edges or corners rounded off, because then your contamination level will be less. There will be less accumulation of dirt and dust if you have a round off corners. The floor is important. Type of finish, slope, give some slope so that you can wash 1/8 inch to 1/4 inch in 10 feet. Drains, provide drains for draining water. One drain for approximately 400 square feet area, and floor insulation, vapor barrier. These are the important things. Expansion, as I already mentioned, provides some space where you will be doing the expansion, not only for the cold rooms, but also for the machine room. Lot of places we find there is no space to locate extra machinery like compressors, condensers, etc. Non-loading bearing valves and insulated panels. This is a racking arrangement. Racking these days, people don't keep the product in a basket or in gunny bags except potatoes, but structural racks and product properly packed is important. 35 feet, 36 feet clear height and 30 feet reachable height with the help of forklift. These are some of the guidelines for constructing, and these are the two row deep boxes or loading racks. You can see these loading racks. Now panels. When we come to panels, there are two types of panels. Camlock panels with plastic hoop. These camlock panels are used for small sizes rooms and where the internal pressures are very high, like blast freezers. The pressure, the quantity of air circulated is so high that it imposes pressures on the walls. And camlock construction is more stronger and it withstands those high pressures. But the 90% cold storages these days are big cold storages and they are using continuous panels. These are the continuous panels which are, there are many manufacturers in the country and different types of continuous panels. Preferred ones are puff panels, polyurethane foam panels. So these are recommended. This is a steel structural cold storage, you can see, and now it will be externally covered with the panels. Floor insulation, for that I suggest use extruded polystyrene. Extruded is important, not expanded. Extruded polystyrene. Wall panels, you can use puff polyurethane foam, and for roof, use polyisocyanurate panels because they are better load bearing types and they can take higher spans. Exterior building construction have a tilt up construction at the dock level because your all trucks will not be of the same height. Some will be medium sized trucks, some will be containers, some will be normal trucks. So your uh, tilt up construction is required so that it can align properly with the vehicle. These are the sliding doors. You can see the sliding doors. The most important point I want to tell you that sliding doors always don't support them from the floor. They should be the part of the panel, that is support them on the panel wall. Why this is important, I have seen many cold storages, if you support them from the floor, the expansion and contraction, when the temperature is reduced, the gap is created because the door does not move. Door remains with the floor, whereas the internal wall of the panel moves inside and the gap is created. So panel and door should move together. That is important so that there is an airtight joint. These are few tips I am giving to make a good cold storage construction. This is a PVC curtain 2 millimeter thick. When the door opens, the outside air should not directly leak in. So there is a PVC curtain. There are various types of curtains. We'll go into this. This is an air curtain, which is a on the outside of the door. There is a fan and fan fitted and casing so that the air movement outside and air movement inside, they are bifurcated and a sort of air screen is created. The advantage of air screen is the movement of people is not restricted. With plastic strip curtains, every time you take inside the trolley, the curtain gets disturbed and the person also feels a little awkward about entering. So these air curtains are also popular. And next most important slide, I don't know whether how many of you have come across. I will not go into too much details, but there is a company in Europe, HCR model curtains. These curtains are hot air curtains. So the outside air is circulated, which is hot air. Now you know hot air has a higher ability to absorb moisture than the cold air. So hot air absorbs the moisture and the moisture does not enter at all into your cold room. These are very expensive. I've just gone through the literature, but in India, I have not used it anywhere. But these are the hot doors. If you go to the site, you will get a lot of information on these HCR doors. These are the HCR model doors, air curtains, and these are hot and cold doors. A vestibule type also can be constructed with this double conditioned vestibule so that there is a sort of anteroom type which is created, and inside curtain, outside curtain. So these are docking areas for the cold rooms and the insulation. Now we come to insulation. This slide I am just going to show because more insulation means less energy and more saving, but capital cost goes up. So optimization of insulation is important. The U value of PUF panel is 0.023 and polyisocyanurate also around same. There is a separate book we are going to publish in few months on behalf of ISHRE headquarters, which I have written only on insulation. So that will give a lot of information, but insulation you can get information anywhere. So these are the different thicknesses, 80 mm, 100 mm, 120 mm. If you use for the same temperature, you get kilowatt power saving from 20 kilowatt to 13.7 kilowatt. So you get a cost saving of more than 4 lakhs if you do this type of additional insulation. As I mentioned, it all depends upon optimization. These are the recommended suggested insulation thicknesses. I have taken ambient temperatures because ASHRAE and other volumes don't deal with 40 degrees or 45 degrees ambience. They deal 35 degrees ambient. So 35 degrees, 38 degrees, 40 degrees, 45 degrees, and inside temperature, positive temperature, say 0 degrees centigrade. And the second set is again 38, 40, 45 with frozen storage, minus 23 degrees centigrade. So these are the thicknesses recommended. I will not read it. It will be available on the website as I will be posting my presentation as usual on the website. The heat gain reduction possibilities, how to reduce heat gains. Same construction, same everything, but use light color panels. Don't use dark color panels. Dark color absorbs radiation. Light color reflects radiation, so less heat gain. Exterior surfaces should be reflective type. East and west walls, if they are exposed, put some shading to avoid direct solar rays hitting the walls, or plant tall trees around so that they give shading effects. Roof exposed to the sun should be covered, and attic places, if you have a dummy partition from between the roof and the panel, that should be ventilated. Otherwise, there will be a condensation problem. These are some of the construction details. I'm not going to go into too much details, but these diagrams, I want to highlight only the main thing. You see, this is a Y shape. This is an inverted Y shape steel fabricated channel. So advantage of that, why I'm saying, inside there is a concrete and this is a panel. The expansion and contraction are different, different, and the gap is created, and there can be many times I have seen between the concrete and the insulation wall, the water seeps through and the cracks are developed in the concrete. So this Y-shaped channel is very important, which ensures that the water is falling on the panels. It is drained off directly. It does not enter into the gap. This similar type of construction for the wall. This is the roof construction. Now here why I want to show you on the roof have this projection so that rainwater is falling on the roof does not fall on the wall of the insulated cold storage. It is diverted away and it falls off. So this is the important portion. Here if you see, some people provide even a gutter so that the water can be collected into the gutters, and then this water can be reused. These are the partition walls on both sides. There is, if you see, there is a concrete on the either side, and these are the roofs construction walls. This is the slide which is most important, which I wanted to show you. In most of the 90% cold storages, I have seen the roof is suspended, puff panels are suspended from the roof with a steel rod, stainless steel rod or a MS rod with a nut and bolt. And nut and bolt is a cold storage. And there is a constant, because of the condensation, steel being good conducting medium, there is a condensation and water is dripping on the floor. So to avoid that, this is a plastic, the polyester available section, and the steel bolt is protected. No condensation will fall on the floor. This is important. In most of the cold storages, you will find when your drain water or your cable trays or anything is taken inside, there is an opening made after the cold storage is constructed, and with the result that there is an opening which is subsequently filled in, and it looks very bad aesthetically and creates a problem. So better to construct in the initial stages. I have written a book, Suggested Installation and Operation Practices for Field Erected Ammonia Systems, which will give more details. This is published by AAR. It will be available with AAR. But this drain piping from the air cooler, you have to have a S-trap in this outlet, and this S-trap should be, the drain pipe should be brought defrosted water directly up to the ground level. Don't leave it at the height, because then the back pressure is created and your water won't get drained off. The defrosted water, you can, if it is lot of defrost water, if you are operating in humid situations, you can use this defrost water into your evaporative condensers and thereby bring down the discharge pressures and reduce your energy consumption. Now these two slides I will show you. These are ready to use fittings available. This is a steel pipe and a insulation and covered with insulation, and this can be embedded into your panel, vertical panel, through which all your steel pipes you can take all your connections, and with the result there won't be any leakage into the cold room. This is another steel construction. This is put into the vertical panel, wall penetration pipe fitting. So these are important points. Floor construction, underfloor heat system, concrete slab. These are the first slab, which is the bottom slab, then concrete sub-slab, then polyester vapor barrier, then 2 layers of insulation, 5-inch, 6-inch, 7-inch, depending upon the temperature. Then again a poly vapor barrier, and then concrete finished floor. So this is the way how to construct the floor. Now floor, especially low temperature floor, heaves up because of the, if it is resting on the ground, it heaves up because of the moisture going through the cracks of the floor, and the ice formation takes place and the concrete cracks up. So to keep the floor little bit warmer, there are methods. Underfloor ventilated air, artificial heating by circulation, then glycol circulation through plastic pipes, or electric heating cables. These are the 3-4 options which one can use to ensure your floor does not get cracked. So these are the floor air vents. I normally use this. These are open from both the sides so that the air automatically flows through this and keeps the floor warmer. This is the glycol circulation system. This is the glycol circulation. These are the pipes through which the glycol is circulated. The next is electrical heating. There is a cable laid below the floor. You will see this is how the cable is laid. Totally electrical cable laid, and then the floor is constructed to keep the floor warm. These are 3-4 methods. Now the roof. If your roof is exposed to sun, cover it with the pebbles. Cover it the pebbles, and you will see in this slide, these are the controls. I did mention to you that I bring all the controls outside the cold room and I'm not inside the cold room, so they can be attended easily, like hand expansion valve, solenoid valve, level controllers for the accumulators, etc. The next slide also shows a walkway on the terrace and the pebbles. The pebbles prevent radiation heat and keeps your roof quite cooler compared to direct solar rays heating. This is the inside concrete wall to protect your panels, and always ensure that whatever penetrations you do on the vertical panels, it should be on vertical panels and not through the roof. Do not penetrate any pipes from the roof because water will go inside. So this is a machine room, a good machine room. It is prepared, and I just wanted to show you a photograph of how the systems are marked, how a provision has been made for the future expansion, etc. This is the electrical switchboard panels, and these are the, I suggest nowadays all cold storages should use LED bulbs inside. The electrical load comes down and the life of the bulbs is extended. So LED bulbs are available for the cold storages, and I have used these. These are less number of bulbs are required. They are more brighter and gives a good illumination. So in part 1 conclusion, as I told you, I will spend more time on discussing construction of a cold storage, how to do a good cold storage, how to discuss with customer, etc. So the conclusion is make a joint statement as what is required and what needs to be done. Construct a building taking into account accessibility, ease of loading, unloading. Calculate proper load, ensuring not more than 4% loading per room, because we don't load load all the product. Suppose it is a 2000 ton potato cold storage, you don't load 2000 tons at a time, not more than 4%. If it is 1000 tons, 40 tons should be loaded. It should be distributed in various rooms, because your refrigeration plant is not designed for the full 2000 ton product load. And then people will complain that the temperature is not being maintained during loading period or during initial stages, and it takes longer time to achieve the temperature. So 4% loading is a yardstick, and please kindly follow this. Your cold storage will not have problem. Selection of different compressors. This is important on the base load and peak load. Suppose your base load is 30 ton and peak load is 100 ton. Select a compressor for 30 ton capacity, one compressor, and second compressor of 70 ton capacity. The advantage is the base load compressor will be continuously running, and peak load compressor can be capacity controlled depending upon your loading and unloading. So a compressor which runs continuously gives longer life than the compressor which runs on-off cycle. So, and then your power savings will be substantial. Don't select two compressors, each of 50% capacity, and third compressor as a standby. That is what normally people do. Select a compressor, standby compressor for base load, and peak load you need not have a separate compressor as a standby. Check the quality of the product. This is very, very important. And when I'm saying check the quality of the product before loading is important. And especially for ice cream, fish, the core temperature of the product should be measured and not the surface temperature. This is important. I will tell you an example. Ice cream storage. During summer, the demand for ice cream is so large that as soon as the cold room temperature is reached, the ice cream is boxes are put into the truck and transported to Bombay or any other city from Ahmedabad. And I have myself experienced that when the truck reaches the final destination, if you open the truck, your product has become already soggy, little bit soggy. It is not as hard as it should be. This is not because the truck refrigeration is faulty. It is because the ice cream has been loaded when only surface temperature has reached the desired temperature. The core temperature has remained high, and then it gradually melts during the journey. Same thing happens with the fish. So always measure with the needle before loading the cold. Otherwise, the consumer or the person who has given you on a rental basis, he will blame you that my product got spoiled in your cold storage. So take the product which is absolutely good while loading. Remember, cold storages do not improve the product. Whatever type you load, in the same fashion, it will be retained. Install efficient equipment to ensure minimum power consumption. Install automation, very, very important, and controls for adjusting plant performance to respond and to match the load requirements. Do not manually load or unload. I have seen many places cold storages when the temperature of the room is reached, one person from the long distance shouts or talks to plant room operator on telephone, अरे भैया जरा आप compressor unload करो, pressure down जा रहा है. So this type of adjustment should not be done. There should be an automatic adjustment to get minimum power consumption. Then in the machine room, provide P&ID diagram, electrical diagram on walls so that the operator is, for him, it is easy to understand. As far as possible, train the operator for a cold storage, which is a low temperature cold storage, or a ice cream cold storage, meat, fish cold storage, or a little complicated cold storage. Maintain logbook of all readings. Either you can manually maintain it, or these days there are controls, Carrel controls or other. They maintain all the parameters and the history of the plant, like energy consumption, etc. So this is the book written on cold storage, written by me. These two books, one I showed you on piping practices, and second is cold storage design. In this book, I have given all the calculations both in SI system as well as in FPS system. And otherwise, a lot of people do a mix match. Last time I saw one seminar where some calculations were in FPS unit, some calculations were in SI units, final load calculation is in BTU, and then it is converted into kilowatt. So don't do that. Either do it in FPS units or SI units. I have given calculations for blast freezers, IQFs, plate freezers, low temperature, positive temperature, all types of calculations, as also the software format. So if you have this book, which is a very inexpensive, 200, 300 rupees, 300 rupees, and you can get it from AAR. Now we go to part 2 of our discussion, which is existing cold storage. Now, existing cold storage, the most important thing, priority, is first to solve the problem. Whatever problem your cold storage owner is facing, we must help him in solving these problems. And then second stage is how to improve the performance of the existing cold storage. What you can go on adding which will improve the performance. So problems, customers always come out. There is huge ice formation inside the cold room, floors, doors, condensation on walls, ceiling, rooms, fogging, misting. These are the mainly construction related problems. Then product not uniformly cooling. Some product cools more, some product cools less. Then foul or bad smell in the cold room. As soon as you enter, there is a smell. Product weight loss. You have loaded 100 tons and output comes 90 tons. It's okay for an inexpensive product, but product like apples, a 10-ton loss is a huge loss. Apples are very expensive. So product weight loss should be avoided. Product shrinking, shriveling, rotting, these are the problems customers face. Then product, they say that it was good during loading, but deteriorated during storage. This I discussed with you. Good during loading, don't go by the external observations, check the product thoroughly. Temperature colder than required, they want to maintain 5 degrees, but it goes to 2 degrees or something. It will consume lot of more power. There will be a wet loss and there will be other problems. Temperature higher than required. The temperature is not coming in the cold room. Temperature is not uniform. It is fluctuating. This is because of loading, unloading problems and capacity control problems. Panels get distorted or collapse. This has happened. I have seen at the beginning of my career, a good cold storage was built into a Pune by one company who was only company at that time in Pune making panels, and they constructed a very good cold room in Yavat, and as soon as the temperature started coming down, the whole panel construction collapsed inwardly. So there was a big loss. They had to reinstall the whole panels once again. So this I will tell you what is the solution. Now evaporator, coil icing, excessive condensation removal, This is because your coil is running at a much lower temperature than desired. Defrost system defective. Storage RH is much higher than designed. That's why there is a lot of moisture, inadequate airflow, and most important is your coil design is incorrect. Lot of people, to save cost, they use high density coil, 6 fins per inch, 5 fins per inch, etc. etc. For low temperature jobs, you should not use more than 3 fins per inch. Then the tubing diameter is very small. In order to save the cost, the face area is less and the depth of the coil is more. That is 6 row deep, 8 row deep coil. Such things should not be done. The coil design is important. In our last session, we discussed few details, but there is a separate book, as I mentioned, I have written for Alfa Laval only on the air cooler designs. The more problem, moisture penetration. Let us see what are the wrong things happening. Why the moisture enters into a cold room? This is the first thing to understand. There is a vapor pressure difference. The outside vapor pressure is higher and inside vapor pressure is lower. Now, when I'm talking, then I'm talking little technical terms. If you, I will interrupt and say that last time I had mentioned that if you want to become a good refrigeration engineer, you must learn the pH diagram, pressure enthalpy diagram thoroughly. If you want to understand the air properties absolutely thoroughly, a very complicated subject compared to pH diagram is your psychrometric chart. If you learn psychrometrics, then you become very good air conditioning engineer. And if you know both the diagrams very well, go on studying them constantly. It is like reading your Bhagavad Gita or like Bible. More and more you read, more and more you look at these two diagrams, more and more things become clearer to you. Lot of psychrometric charts, if you see on the y-axis, they give moisture content, that is grams of moisture per kg of dry air. But there are very few psychrometric charts which indicate the vapor pressure, that is outside vapor pressure uh, at that temperature. I have some psychrometric charts which indicate both moisture content as well as vapor pressures. So vapor pressure inside, when the air is cooled, the vapor pressure decreases and the inside pressure decreases, outside pressure is more, and because of the vapor pressure difference, moisture tries to penetrate. Also, I told you that the walls collapse if inside pressure, because of the density of air goes up when air is cold, and density is less when air is hot. So when density increases, the internal volume decreases and the panels collapse. So this is the vapor pressure difference. And just to make it more clearer, I want to tell you that don't go by RH. Relative humidity is a very misnomer. Lot of people talk about relative humidity, but that is a wrong terminology. Relative terminology only indicates ability of the air to absorb additional moisture. It does not indicate the quality of air. For example, just take the first table. The temperature one is 5 degrees centigrade, second is 15 degrees centigrade, and the moisture content, if you see from the psychrometric properties, although the RH is same, the 15-degree air, because as I mentioned, hot air has ability to absorb more moisture, is 1.2 grams per kg. So nearly 2 times the amount of moisture is there in at the same relative humidity if the temperature changes. Similarly, in the next slide, table you will see, I have maintained here the same moisture content, that is 0.6 grams per kg. but the temperature changes 5 degrees to 30 degrees. What happens to relative humidity? 5 degrees air with 0.6 has 90% RH, and 30 degrees centigrade is 20% RH. That means it can absorb additional 80% moisture when the temperature is 30 degrees centigrade. And when it is 5 degrees, the air is already saturated. There is hardly any moisture. Why I'm going into more details of this? Because a lot of people I have seen, to increase the humidity, they put foggers inside the cold rooms and to increase the humidity. The foggers do not increase the humidity. What happens that moisture goes on, settles on the product. It is like, just to give you a common example, if you take a toothpaste early in the morning for brushing your teeth, and if you take out the paste, if you take excess space out of it, can you put it back into the tube? No, you cannot put it back. That is wasted. Similarly, same thing happens when there is a more moisture in the air and it is condensed and it forms into an ice, because ability of the air to retain this moisture is not there. It is already saturated air. Excess moisture gets converted into a fog, mist, or if it is a low temperature room, into ice. So this is important. Remember the difference between humidity content, specific humidity, and the relative humidity. Always talk in terms of specific humidity or a dew point temperature. If you listen to BBC or CNN, nowadays they have stopped talking about relative humidity of the atmosphere. When they give atmospheric conditions, they talk about dew point temperature and the dry bulb temperature. Dew point temperature is more important because it tells the moisture content into the air. Relative humidity does not tell you this. I'm stressing spending more time on this. For example, in the glass, if your glass is full of water, if you consume 20% water of that, that glass has the ability to take 20% extra water. So the relative humidity of that glass compared is 80% because it can take 20% additional water. If you empty the glass, make it 10%, then the ability of the glass is to take 90% more water. So this is like comparison of RH. Now you see this vapor pressure difference at 40 degrees and 30% RH. The moisture content is 13 grams per kg, psychrometric properties. At minus 40 degrees, it is only 0.07 grams. And the vapor pressure difference, which is a driving force, as the air travels from warmer to colder side, as we discuss, always temperature transfer takes place from high temperature to low temperature. For transferring from low temperature to high temperature, we require external energy. Similarly, moisture always will travel from a higher vapor pressure level to a lower vapor pressure level. So vapor pressure difference is important for checking the moisture content in the room. Now, most important slide, to cool 1 kg of air, you require one this milliwatt or 0.24 BTU per pound. To condense 1 kg of air, you require 2,500 times more energy. So you can see how much extra energy you require when you want to use, you are producing ice or fog or dew inside the cold room more than what is required. Some condensation will take place. That will be because the air gets cooled and that will be drained off during defrost or in your drain pans from the air cooler. More than that, excess moisture should not be there in the cold room. you see this curtain. This is the same slide from that HCR. The important statement made by Albert Einstein: you can't solve a problem using the same knowledge that has created the problem. If you don't understand this humidity difference, and if you go on doing all sorts of things like draining constantly, water excess moisture, defrosting frequency too high, or clearing the floors, etc., then you are doing wrong. Initially, you should never allow more moisture than required to be formed inside the cold room. Your major energy expenditure will be in generation of ice or frost, and not in cold storage requirement. I have entered into many cold storages where the entire floor is iced. Even in Pune, I have gone to 3 cold storages, -20, -30 degrees centigrade, and you can't walk on the floor unless somebody holds your hand, or if you, because you will slip. There is so much ice formation on the floor. So these are the wrong things. This is the fog formation in the cold rooms. This is ice from the roof. It is all, if you look at the roof, there is a hell of a lot of condensation, or at -20 degrees, there is all ice formation. So this should be avoided. So when you find that your ice so much more than expected is getting accumulated, the best way is to do insulation leak test from where the moisture is leaking in. As I told you, ice formation takes place only because of vapor pressure difference and not because of your product which is having higher moisture content. That higher moisture content will be reduced once you cool down the product, and it will be drained off from the drain pan if it is a positive temperature room. If it is a negative temperature room, then you have to defrost periodically, but not too frequently. So these are the thermography. There's camera pictures, and there is a software. The red spots you will see where the air leakage is there. Now these air leakages are not visible to naked eye, but if you do thermography, you will be able to locate. For example, your conditioned premises should be -21 degrees centigrade. But where these red spots are there, you will find the temperatures are 17 degrees centigrade, 13 degrees centigrade, like this. That means lot of outside air, which is at 23 degrees centigrade, air is leaking in, and the force is very high because of the vapor pressure difference. These are the doors, corner of the doors. I've seen, just visited 2 months back, a cold storage. For opening the door, we had to literally use hammer. The door was opening inside, but we couldn't open the door because there was so much ice formation. It was a -20 degrees room. So such things are very normal in existing cold storages. This is the panel. If your panel is not continuous formation panel, and if it is a batch production, there could be a possibility of gaps or voids remaining inside the panel, and that could lead to temperature differences. The edges need to be right hand side. They need to be properly sealed. These are the doors leakages. At the bottom, there is a leakage. You can see the temperature has gone up to 21 degrees centigrade at that point instead of 23 degrees. So this thermography helps a lot if you suspect moisture leakage. Coil defrosting. The coils sometimes are ice so much. I have seen the drain pans. The drain pans are totally full of ice. Even if you defrost the coil, the water which is falling in the drain pan spills over and falls into the cold room, because drain pan, the ice slab is formed there, a total ice slab. So such things should not happen. This is the calculation, defrost load calculation, how much energy you spend in forming 1 pound of ice, 0.7 kilowatt nearly. I will not read all the points. This will be available to you on my presentation. So 0.66 kilowatt per hour is the power required to remove 1 pound of frost or ice. So you can see, measure the quantity of ice, measure the condensate water, and you will find how much energy you are wasting in ice generation. Many times I call it, when I enter this minus 20 degrees cold storage, I tell the customer, look here, you have not made a cold storage, you have made an ice factory. It is generating more ice than storing your product. So such things should be avoided. Many times this is done. First slide, a separate circuit for drain pan, because if there is too much frosting on the coil, the entire hot gas will be utilized in coil defrosting and nothing will be left for drain pan defrosting. A separate circuit can be provided, hot gas separate, for to keep the drain pan clean, and more drain holes. Normally I insist for 2 to 3 drain holes into a drain pan of a sufficiently larger size. Product drying, weight loss of the product. As I mentioned, you must learn the psychrometrics. This is a psychrometric chart, and this shows the temperature difference. As your temperature difference TD1 and TD2, as the temperature difference goes on reducing, your ADP, apparatus dew point, goes on improving, and there is a less moisture condensation. As your TD2, if the delta T is much more between the room temperature and your coil temperature, there will be lot of condensation and your product will become dry. More moisture will be removed from the product. By putting foggers, you cannot increase your moisture content. You can increase the moisture content in the air, but product wet loss will definitely take place. So maintain low delta T as much as possible to reduce the product weight loss. This is important especially for vegetables, fruits, not for the negative temperature. There you can have a little bit of higher delta T, because their relative humidity of the product is already frozen. These are the delta T's recommended. Cold room temperature and evaporating temperature, these are the delta T's suggested. Smaller the temperature difference, lower the dehydration rate and higher air humidity. A temperature difference of 4 degrees centigrade can be only achieved with, you can use electronic expansion valves also. Product not cooling uniformly, temperature variation is too high. This is because of loading, unloading is not done very quickly. The air spaces are not left between the product. A very common phenomenon in most of the cold storages. I've seen some Paratha cold storages in Ahmedabad area. The products are stored one above the other in a heap and it is exported. So only the top layer and the sides are getting cooled. The core temperature, every product is not getting cooled. This is how the products are stored. The products are stored right up to the top of the air coolers. So air circulation is restricted, etc., etc. So storage of product, air distribution is very important. Store a product in such a manner that there is a total air circulation all around every box. This is important to maintain uniform temperature of the products. there should not be heat packages. The fan laws, I will not go through with these, but I just wanted to tell you that your air is not reaching the other end. If you just increase the speed a little bit, your air can reach for a longer distance. The it the travel of air is quite a lot if you increase the speed a little bit. I will not go into the details of that. Recommended cooler placements is also important. And finally, automation. This is a slide which I wanted to show you where the pressure equalizing valves are important on a good, well-designed cold storage where there is no air leakage. So in order to that the panels do not collapse, you need to have these air vent valves which equalize the outside and inside the pressure without allowing air to leak in. So these are equalizing valves. I always install on my cold rooms these equalizing valves. These are available. The system capacity, very important. This overall system capacity depends upon the all the components working together, balancing. Individual component may influence the capacity, but does not. The weakest component in the system will determine your system capacity. Causes for high discharge temperatures, pressures, overcharged systems, non-condensables, inadequate water supply, bad water quality. I will not go into reading because of the time limit. Is your cold storage consuming more power than expected? Recheck the design parameters. Find out the areas where they are not meeting the design parameters. Check for insulation leakage performance, frost formation, selection of air coolers, whether capacity controllers, thermostats are working properly. Install additional automatic controls. Make a plant operation automatic as much as possible. Check oil balance, quantity of oil drained and quantity of oil charged. If there is an excessive oil in the system, then also your system performance will be affected. Check whether there is excessive moisture accumulated in the system because ammonia is a good absorber of moisture and buckets of water has been removed from ammonia low temperature systems, especially those work below atmospheric pressure like blast freezers, IQFs, which work at minus 40 degrees centigrade. Ammonia boiling point is minus 33 degrees centigrade. So the plant is working constantly under vacuum. Install water rectifiers, automatic air purges in such cases. Visual checks and operational checks are important. Install pressure relief valves on panels so that panels won't distort, we discussed. Controls are the most important. A good control system can make a marginally installed installation, marginally designed installation operate satisfactorily, while a poor design system cannot make even the best designed installation operate satisfactorily. So controls play very, very important roles. Evaporator pressure control is very most important controller to maintain the product quality. Maintain irrespective of the load, constant evaporator pressure as designed, and then your product energy saving will be tremendous. It will reduce product weight loss, it will reduce defrost frequency and energy saving. VFDs are many times installed for part load operation. These are dual safety valves which are very important because one safety valve, if it blows off, you can, without stopping the system, your second safety valve, you can bring it into operation. Quick drain shutoff valves are very important because then it provides as a safety. When you release the handle, the valve automatically shuts off. This is an installation. This is ICF controller. You can see it avoids nearly 12 welding joints. This is the top line is a standard line, stop valve, filter dryer, solenoid valve, non-return valve, etc., etc., and then again a valve. So 12 joints, whereas ICF control, if you provide, these all controls are built in. There are only 2 points where you have to do the welding. These are the ammonia leak detectors. Install them in the machine room. Use automatic flow regulating valves instead of hand expansion valves, especially in the pump circulation systems. And these are the monitoring panels, cold room panels. These are the panels, refrigeration panels with PNID printed on the panel, so you know exactly what is happening where, what is happening in compressor, what is happening in LP vessel, what is happening in evaporative condenser, and what is happening in the cold room. So these panels are very, very important. These are available now in your printed circuits, and they can show temperatures very, very accurately. These are door opening and closing also recorded, how long the door was open, how many times you open the doors. So areas of improvement: standard vapor compression cycle, heat exchangers, frequency control fans, adjustable speed dives, automatic air purgers, water rectifiers, and computer electronics monitoring all parameters. Daily log sheet readings, I will not talk about it. We have already, I think, exceeded our time by 3-4 minutes. But the conclusion is keep the discharge pressure as low as possible. Keep suction pressure as high as possible as demanded by the design. Keep the superheat bare minimum. Maximize subcooling. Use VFDs wherever possible. Use water-cooled condensers instead of air-cooled condensers. Use continuous responsive electronic controllers who can monitor fluctuations, constant fluctuations, and gives continuous response. Keep layout compact. Do not over-design the equipment. Size refrigerant piping with minimum pressure drops. Ensure proper oil management. Do not over-select motors or pumps. Keep water side pressure drops minimum. Remove non-condensables waters periodically from the system. Keep descaling constantly. Keep filters, coils clean. Ensure daily, weekly, monthly as per the maintenance schedule, and follow preventive maintenance practices. If you follow all these 18 steps, I'm sure your cold storage, existing cold storage, will start saving nearly 20 to 30% power. I have done this. This is I'm talking based on not on theory, but my personal experience. I think with this, I have just exceeded 4-5 minutes, but I will sign off. I will take your leave at this time, and I will hand over back to the organizers. Thank you very much for patiently listening. Any problems, let me know. These 2 books which I have published will give you a lot of additional details. And besides that, if you have any questions, let me know. Thanks a lot. I once again thank you, Ishri, and hand over back to Ishri. Goodbye.
Thank you, sir. Thank you. It's a very wonderful presentation, very useful. It requires experience to deliver such a wonderful presentation in such a short time. And all your experience, we can see you have, with a lot of interest, prepared this and condensed, and really we could see for constructing a new plant as well as trying to solve problems in an existing plant. You have given a very detailed presentation. Thanks a lot for this presentation. Ravi?
Yes, sir. Salon in this side.
Okay. So our next program will be on coming Friday, and you can all log in. The details are available. Thanks the participants for your time, and we'll look forward for your presentation participation in the coming week. Okay. Thank you then.
Thank you, sir.
I know. Yeah. Thank you. Bye.
Goodbye. Good day. Good night.
Good night for you. Yeah.